3 times 2 times 1. Very good. 3 factorial is 3 times 2 times 1. Three times 2 times 1. Very good. 3 factorial is 3 times 2 times 1. Three factorial is 3 times 2 times 1. 3 times 2 times 1 is called 3 factorial.
Yes.
Agree. This is called 3 factorial. Now, what is 4 times 3 times 2 times 1?
4 factorials.
4 factorial, right? What about this part?
3 factorial.
That means 4 times 3 factorial is equal to
4
4.
factorial.
Agree?
Yes.
9 times 8 factorial?
9 factorial.
9 factorial. 24 times 23 factorial?
24 factorial.
Right. Now, coming to the question. First, this is 1. We are writing 1 as it is easily. 1. Next, this is 1. This one is changed as 2 minus 1. Agree?
Yes. Yes, sir.
Into 1 factorial. What about this term? It is 2. 2 is 3 minus 1
Yes.
into 2 factorial. Next, how to write this?
4 minus 1.
Yeah. 4 minus 1 into
3 factorial.
plus so on. Last, how to write this number? As before, as the previous numbers. It is n.
N
Yeah.
minus
No,
1.
no. See, 3 is written as 4 minus 1.
Oh,
Is added and immediately 1 is subtracted.
yes, sir. So,
Hmm.
N plus 1 minus 1
N plus 1.
minus 1
Okay. Times
times
n factorial.
N factorial.
Clear?
Yes, sir.
See. 1 plus 2 into 1 factorial. Can you tell?
2, sir.
No. Previously, we did some practice on it. 20 into 19 factorial is equal to?
20 factorial.
Yes. Same way.
Oh, 2 factorial, sir.
It's very good. 2 factorial. Minus 1 into 1 factorial. 1 factorial only. 1 into anything itself.
Yes, sir.
1 into x is equal to x. 1 into y, y.
Right.
Now, what is 3 into 2 factorial?
3 factorials.
Very good. 3 factorial. Next, minus 1 into 2 factorial.
2 factorial.
Very good. Plus
4 factorial.
very good.
Minus 3 factorial.
Plus so on.
So,
n plus
till
1
N
times
factorial.
n plus 1 times n factorial. 20 times 19 factorial is equal to 20 factorial.
Yes, sir.
So n plus 1 times n factorial.
N plus 1 factorial.
Very good. It is n plus 1 factorial. Minus
N factorial.
That's good, right?
Yes, sir.
Now, first term is 1. This is second term. Next term. Okay. Can you do any cancellation? Can you do any cancellation?
Sir. Positive 2i, sorry, 2 factorial, negative 2 factorial.
Cancel.
Can we cancel, sir?
Yeah, you cancel.
So it's that 3 factorial, negative 3 factorial. Yes, sir. Oh, yes, sir. That's it.
Continue. Cancellation.
So it will be 1 minus 1 factorial.
See, what
Plus
about? See, one thing.
factorial.
Why are you writing 4 factor? Okay. See, okay, you are right. See, what is the meaning of ...
It continues so on.
Continues on. Okay, right? ... means continues. So once clear the last. Okay.
Yes.
Very good. Okay. Yeah. ... Oh, can you guess the next term?
5 factorial minus 4
5
factorial.
factorial minus 4 factorial. What should be cancels?
The 4 and the 4.
4 factorial cancels. This
Yes,
also
sir.
cancel. Okay, this cancel with previous term.
Yes, sir.
This cancels the next term. Next term
Yes,
is there or not?
sir.
Next term is there. So on means ...
Yes.
So on means there are terms are there. Okay.
Yes. Yes.
So 4 factorial is also cancels. See, see, the second term cancels with the previous term.
Yes, sir.
The factorial is cancelled with, okay, cancelled with the previous term. Cancelled with the
Yes.
one which is in previous term.
Yes, sir.
If there is no previous term, that means if the series ends here, -3, 4 remains uncancelled.
Yes, sir.
If the series end here, we cannot cancel 4 factorial.
Yes, sir.
4 factorial is cancelled with someone in the next term. Something in the next term. Okay. If it ends here, 4 factorial remains uncancelled.
Yes, sir.
But -3 factorial cancels the previous term. Now, what do you say? Minus and factorial cancels or not cancels?
Cancel.
Cancels. Because previous terms are there.
Yes.
What about n plus 1 factorial? N plus 1 factorial? No. Yes?
So, but 4 factorial is can.
Of course, 4 factorial is cancelled with the next term. It is not end here. It continues till n plus 1 factorial minus n factorial, right?
Yes, sir.
We use the we use just for example.
Yes, sir. Got it.
It is not end here, right? Okay, now continue. If you continue, I'm saying that because 4 factorial must cancel.
Yes, sir.
4 factorial cancel because there are terms after this term.
Yes, sir.
That's why 4 factorial cancels. Okay.
So
Now
the answer would be n plus 1 whole factorial, no, sir?
yes, n plus 1 whole factorial cancels or uncancelled.
It's uncancelled. It doesn't cancel.
But what about minus n factorial?
It cancels out with the next term.
Because previous terms are there. Okay. This type of cancellation is called telescopic cancellation. This is called telescopic cancellation. Next, what about -1 factorial? Is it cancels or not? Previous terms are there or not? For this, previous term is there?
No, sir.
Yeah, it is previous term.
Yes, sir.
Previous term is there.
Yes, sir.
Previous term for this is there. So, what is the value of 1 factorial?
1, sir.
This also 1.
That's -1 and this is positive.
Also 1, right?
Yes.
Cancels or not?
Yes, sir.
Wow. So what is the answer?
N plus 1 whole factorial.
That's good.
Option 4.
Right. Option 4 is correct. Very good, very good. Got it?
Yes.
In the previously, we discussed something about P. P stands for permutation.
Permutation.
P is first letter of permutation, right?
Yes.
I'm telling one thing here. Number of ways of arranging n things in R places. Number of ways of arranging n things in R places is equal to NPR. Right?
Yes.
The formula for NPR. The first point, it is second point. The formula for NPR. NPR is equal n factorial by n minus R whole factorial. It is NPR.
Yes.
Got it?
Yes.
Now, N9P5. What is 9P5?
9 factorial by 9
That is
by
9
4,
factorial. 9 factorial by.
4 factorial.
That's good. Plus 5 to. What is 9P4?
9 factorial by 5 factorial.
What? 10
10
factorial.
factorial by 10 minus R whole factorial.
We are simplifying this. Let us simplify this. 9 factorial, right?
Yes, sir.
It is 4 factorial. Plus 5 into 9 factorial by. You remember what is 5 times 4 factorial?
5 factorials.
So this 5 factorial can be written as 5 times 4 factorial.
Yes, sir.
So instead of writing 5 factorial, we can write it as 5 times 4 factorial. Right?
Yes, sir.
Now, what is common?
4 factorial, sir.
9 factorial by 4 factorial is common.
Yes.
There is a mistake in it, I think. 10 factorial. 9P4 value 9 factorial by 9 minus 4, 5 factorial, right? Five into right. One plus 4 by 5. I think it is 4. Right? 4 here. Then it will be 4, right? Now we can take 9 factorial by 4 factorial common in these two terms.
So how are we writing 4, sir?
Yeah, I think it's 4. I think it's printing mistake. I think it is 4. Now take 9 factorial by 4 factorial common. 9 factorial by 4 factorial into. We left with 1 only. By taking common, if there is no term, we can write 1. Agree?
Yes, sir.
Plus 9 factorial by 4 factorial taken common. So what is left?
4 over 5.
Yeah, it is 4 over 5. 9 factorial by 4 factorial. What is simplified form of 1 plus 4 by 5?
1 plus 4 by 5, sir.
Yeah.
LCMs?
Yeah, LCM.
5? Yeah.
Yeah. 1 plus 4 by 5. LCM 5.
5 plus 4, 9 over 5. So.
9 over 5, right? But it should be 10. It should be 10. How to get 10 here?
Yes.
5 plus 4, 9 only. It should be 10 now. There should be 10. How to get 10?
2 plus 4 over 5.
It should be 2. Then it will be no. Let me check it.
Yes.
NP5 plus 5 into NP4. R is equal to 5. So 5 into 5 factorial. 9 factorial by 9 minus 4, 5 factorial. See, what is NPR formula?
N factorial by n minus r whole factorial.
So what is 9P4?
9P4, sir. 9
Nine
times, 8 times, 7 times, 6 times, 5 times, 4 factorial.
Using this formula.
9 factorial over 5 factorial.
9 minus 4. 5 factor.
Yes, 5 factorial.
5 factor only. What about 9P5?
9 factorial over 4 factorial.
Yeah, 9 factorial by 9 minus 5, 4 factorial. Okay, I think it is a mistake. I will check it. There is a mistake in it. I will check it. Okay.
Sir, but 1 second. Sir, isn't for the second one 5 times 5 factorial?
Where is 5 times 5 factor? 5 is in numerator.
Here it's 5 factorial, no, sir.
Yeah, that's good. That's good. Yeah, you are right. Very good. That's a mistake in it. See, let us see. Now tell. The question is, yeah, what is 9P5?
9 factorial by 4 factorial.
Yeah, very good. After that,
Plus 5 times
5.
9 factorial by 5 factorial.
Yeah, 9P4. 9 factorial by
5 factorial times 9 factorial over 5 factorial.
okay. There is a small, there is a comma. Then 5 factor cancels now. If 5 is here, okay.
So we can make it, for the second one, we can make it 9 factorial by 5 times 4 factorial now, sir. So the 5 and the 5 gets cancelled.
5 cancel. That cancels. Okay. NPR is equal to n factorial by n minus r factorial.
So it's 9 factorial by 4 factorial plus
Same
5.
Same. We'll get same. 9 factorial by 4 factorial, 9 factorial by 4 factorial, same.
Yes, sir. 9 factorial by 4 factorial plus 9 factorial.
It should be 10 PR. 10 PR means 10 factorial by something. Okay, we will do it later. I will check for correction. Do you have functions?
No, sir.
Functions.
Function. We have only domain and range, those functions.
Okay. Now, it's a concept regarding number of functions. Do you know what is a function?
Yes, sir.
See,
When the I know it in the graph model and the
is it
Venn diagram.
1, 2, 3,
Oh, yes, sir. That one and in the graph.
4, 5, 6.
Yes, sir.
This is a function,
Yes, sir.
right?
Yes, sir.
But this is not a function
Yes, sir.
because one has two images.
Has-
One has two images. That's why it is not a function.
Yes, sir.
I'm asking you, first set has two elements. Second set has two elements. How many functions can we make?
2, sir.
Only two. This is one function.
Oh, then 2 can go with 3 and 1 can go with 4.
1, 2, 3, 4.
3, 4. So 2 can go with 3.
It's also function.
So, but
See,
oh, yeah,
it is not a function because one has two
one
images.
yes, sir. Got it.
But
Yeah.
1 and 2 have same image.
Yes, sir.
It is accepted as a
Yes,
function.
sir.
Now 1, 2,
3,
3, 4. This is also function.
yes, sir.
1, 2, 3, 4. This is also function.
Yes, sir.
How many functions are there?
4, sir.
4. So there is a formula to find number of functions. This is set A. This is set B. If number of elements in it are M, A contains M elements.
Yes.
B contains N elements.
Yes, sir.
Here A contains 3 elements.
Yes, sir.
B contains 3 elements.
Yes, sir.
Here A contains 2 elements.
Yes, sir.
Contains 2 elements.
Yes,
Here
sir.
A is called domain.
Yes, sir.
A is called domain.
Mine.
It's called codomain. Codomain.
Oh,
Range is different from it. Range is a part of codomain.
oh, we never came across that.
Ah,
We only know about it as domain and range.
range. Range is a part of codomain. I will explain what is range. See, domain contains M elements.
Yes, sir.
Codomain contains
N elements.
N elements. Now, number of functions. Number of functions. Formula. See, here we have 4 functions. Because this contains 2 elements, this contains 2 elements. Totally number of functions are 4.
Yes.
The reason is, the answer is n to the power of m.
Yes.
So, number of functions formula. See, I'm writing clearly here. Formula to find number of functions. Have you watched that video which contains the solutions of the question paper?
Yes, sir.
Yeah. First day our payment from YouTube is 1 rupees 97 paisa. 97, yeah, 1 rupees 97 paisa. Of course, so it gets us slowly. 1 rupees 97 paisa. Yeah, by watching. Not think. Yeah, something like that. By our yesterday's live class, YouTube. Okay, it's not correct to announce. It puts 99 paisa for in account. So we can improve it. We got idea how to what's the process. See, I am preparing videos, general videos and subject videos. I request you to share it as much as possible after preparing. Number of functions formula. Okay. Number of elements in codomain are simply n to the power of m.
Yes.
where n is number of elements
In
in
core
quadrant,
domain.
and m is number of elements in domain. Right? By
Yes.
using this formula, can you answer this question?
The number of containing 5. Oh, 5 to the power 4. So,
Right?
sorry, 4 to the power 5.
Yeah. Mark the correct option.
Option 2, sir.
All are asking for why class is not open. Class has not started yet.
A different link, no, sir.
Because they are entering even at 5. Some students, you may feel disturbance. That's why I allot separate link. Join at 5:40. See, all are trying. Many are trying to enter. Yeah, that shows meeting has not started yet. Something, some in another meeting, something like that. Okay.
It will just show that the host has not started the meeting
Yeah,
yet.
right, right. It is 4 to the power 5, right?
Yes.
Now, it's about number of 1 functions. See, among these functions, this is not 1 1. This is not 1 1. This is 1 1. This is 1 1.
Yes.
Why this is not 1 1? Two different elements have same image. Whenever two different elements have same image, it's not a function. So, of course, it is not 1 1 function.
Yes.
The name, another name of 1 1 function is injection. Injection and 1 1 same. 1 1 function 1 to 1. Okay, 1 to 1. 1 1 function and injection is same. See,
Yes.
in it, these are not 1 1 functions because two different elements have same image.
Yes.
Whenever in a function, if two different elements have same image, then it is not 1 1 function.
Yes.
Of course, it is a function.
Yes.
Let me give an example for a function which is not 1 1. 1 2 3 4 5 6. It is function but not 1 1. Give an example by joining.
3 3 5
3 5
1 5 2 6.
2 6, right?
2 6 out of
It is a function but not
a 1 1 function.
now.
1
Give an
2
example for a 1 1 function.
1 6 2 5 3 4.
Yes, it is 1 1, right?
Yes.
Now I'm telling the formula to find the number of 1 1 functions. Number of 1 1 functions.
Yes, sir.
That are injections.
Yes, sir.
Number of injections. Number of injection formula NPM, where N is number of elements in quatermain, M is number of elements in domain.
Yes, sir.
Okay. Now answer this question.
Sir, before that, I sent you a picture for the question, sir. Can you kind of check?
Yeah. Answer this question.
Yes, sir. The number of one function that can be defined A equals ABC and B equals B1, 2, 3, 4, 5. So is it 5p to the 5p3?
Yeah, that is 5p3. Very good. Mark that option.
Yes.
What is that question?
So it's
So which of the equations could be used to determine where on the roof the rocket land? Is it land?
Yes, sir. Yes, sir, land.
The roof of the house has a pitch of 4:3. Okay. Where the pitch compares the vertical rise of the roof to the horizontal run of the roof. The diagram shows a under at the origin and the because of the rocket. Okay. Which of the system of equations could be used to determine where on the roof of the rocket will land? So the rocket will go and land on house.
Yes, sir.
We need to prepare equations. Two equations are there. Each option has two equations.
Yes, sir.
Y is equal to 3 by 4x plus 9. Y is equal to x squared minus 10x plus 9. Okay, it should be an equation, right? Okay, got it. On the roof, what are the points on the roof?
So the starting of the roof is 12, 4 comma 12, and then
See, yeah.
yes, the
One
starting of
is
the roof.
4 comma 12. No, not 4 comma 12. 5 comma 13.
So it's on the roof, no, sir, but it can start from
Yeah. Okay. 4 comma 12. 5 comma
Yes.
13.
Yes, sir.
And 6 comma.
6 comma
No, we
no,
cannot
sir,
find.
7 comma 14. 7 comma 14.
Yeah. First, take first point 4 comma 12. Must be satisfied by the first equation and also second equation.
Oh, yes, sir. And then 7 comma.
Yeah, we need to set the options which satisfies that. Okay, can we connect there?
We can just find this slope also, no, sir. So we can eliminate 2 options then.
Yeah, right. Eliminate options. Come there. Can you come there? They all are waiting. Tomorrow we'll start at 4:30 only. Yeah,
Now, yes, sir, I'll see once.